Dear students, so let's see what B plus tree is in this lecture video. So B plus tree is nothing but a tree data structure. So it is used in the area of storage of records in the database. Uh, if we just arrange the records or store the records in the format of B plus tree, so the structure helps in locating a particular data in the storage, and also it facilitates insertion and deletion in an efficient way. So let's see this B plus tree with an example. So in the exam point of view, they will be giving the questions like this. They will be giving some values like this, and then they will give either order of the tree, or they will give number of pointers. So based on that, you have to derive the solution for this problem. So problem is nothing but we have to store these values. That is, these values are nothing but records. So that has to be stored in the format of a B plus tree. So which helps the storage and retrieval of their records effective. So let's first take the given values. So they have given 26, 27, 28, 3, 4, 7, 9, 46, 48, 51, 2, 6 in this question. So another thing what we need is, before solving the problem, we need the what is the order of the tree. So in this example, they have given the order as 3. Actually, the node in the B plus tree will be having two aspects, or it will contain two things in a node. One is pointers. The first one is pointers, and the second one is values in a node. So based on this order only, we will be determining the number of pointers as well as the number of values. So the number of pointers will be equivalent to the value that is given as order, and the number of values will be equal to the value of order minus 1, that is 3 minus 1 equal to 2. So from this we get what we get is uh, uh, so these three represents the number of pointers that will be present in a node, and these two represents the values that will be stored in the node. So so let's start the problem, or let's start inserting the values in the node. So in the step 1, the node will be like this, because they have given the values, number of values to be 2 and the order to be 3. So based on the order, we design the node with the 3 pointers and 2 values. Okay. So in the step 1, since 2 spaces are available, 2 values can be inserted, we are taking these 2 values, that is 26 and 27. So we can directly insert it. So and these values should be in ascending order. So the values in the node should be in ascending order. So this thing you have to keep in mind. And then in the step 2, so we try to insert the new value, that is 28. That is insert 28. So this 28 has to be inserted in this node. But already 2 values are available in this node, or accommodated in this node. So the insertion of third value is not possible, because it can only accommodate 2 values. So then we have to follow or then we have to move on to some other way. So what we have to do is we have to just take the values inserted in the previous node, that is 26, 27, and then the new value to be inserted, that is 28. So then we need to arrange it in ascending order, and then we have to find the median value. Median in the sense how we have to, how the formula to find the median is the number of values 1, 2, 3. So 3 divided by 2. So it gives 1.5. So it has to be rounded to the nearest value, that is 2. So then these two actually represents the position of the position that position of the element that we have taken. So these two actually represents this element in the second position, that is 27. So after that, what we have to do is we have to just decompose the existing node, that is the node obtained in the first. So in the second step, what we are doing, we are creating a root node. So all the nodes will be having the same 3 pointers. So we are creating a root node, and we need to insert the middle element or the value that is represented by these two. So as the root node, and then the value that is lesser than should be kept as left node. It is 26. And in the right hand side, here you have to observe carefully that on the left hand side we are keeping the lowest value. In the right hand side we need to insert the highest value here. But in the B plus T, what we have to do is we have to once again insert the value in the root node and then the biggest node. So in the B plus T, the right hand side of a particular value or a right hand side pointer of a particular value will be consisting of or it will be representing the node which has the values of that values greater than that particular value as well as the copy of that value. So to put it in a simple way, the nodes the nodes in the left hand side will be having the values lesser than the root node, and the right hand side will be having the values greater than the root node as well as the copy of the value in the root node. So till step 2 we have inserted 3 elements. So coming to the step 4, step 3, we need to insert the value 3. Okay. So what you are trying to do is uh, actually this 3 has to be inserted. We are trying to insert this 3 here. So what we have to do, this 3 we are just comparing. Actually the procedure to insert this 3 is first we have to compare this 3 with the root node. Since it is lesser than the root node, it has to come to the left hand side. The value has to be inserted here in this node. It has to be already in the first position. Some value is there, so we cannot insert here. But anyhow, the 3 has to be inserted in the left hand. So that what we are doing is this 3 and 26 we are taking ascending order. So and then we are pushing the 26 here, and then 3 will be coming here. So in the third step, the tree structure will be consisting values like this. So on the left hand side, it will have 3, 26. In the right hand side, it will have, as I already said, copy of the root node as well as. Okay. So till the step 3, 4 values are inserted. That is, so and then So in the step 4, we are just trying to insert we are trying to insert the value 4. Okay. So as I have mentioned earlier, this 4 has to be inserted here in this previous tree, in the previous derived tree, in the sorry, in the tree that has been derived in the previous step. So what we are just trying to do is we are trying to insert 4. While the same procedure has to be followed, we are just comparing it with the root node. Since it is lesser than the root node, it has to come here, but already 2 elements are accommodated in the node that is coming as left hand side node of the value 27. So here we cannot insert, already 2 elements are there. So what we have to do is, again we have to follow the same procedure what we have followed here. So these 3 values, that is 3, 26 and 4, are taken and they are arranged in ascending order, that is 3, 6 and 24. We need to find, actually the total number of elements are 3. So the number of elements divided by 2 equal to 1.5. Again it comes 2, and this 2 represents the element in the second position, that is 6, sorry, 4 is to be inserted, no? So then here it comes 4. It comes 4. Okay, then this 4, then 4 should be taken to the node in the upper level. So what we are doing is, here we are trying 4 but no place. So what we are doing, the middle element, that is 4, is pushed to the top upper level of the node in which the 4 has to be actually inserted. So then if it goes upper, then already 27 is there, and then we need to compare those two values, and the smaller value will come occupying the first position, and the higher value will be moving to the next position. So again we have to reorder the values that are below the root node. So what actually happens is, here we try to insert 4 but it's not, so that we are just taking it to the higher level. So then what will happen here is, so we are trying to insert 4, so you cannot insert here, so we are doing this operation and we are taking 4 to the upper level. So already 27 is there, so since 4 is smaller than 27, it occupies the first position, 27 comes after. So here the values which are beneath the root node has to be reordered properly. So what are all the values actually in the leaf node, that is 3, 26, 27, 28, they have to be arranged properly. So first we are taking 3. So the value which are lesser than 4 will be coming here. That is 3. And then Here in the right hand side, as we already said, right hand side value will be having a copy of the value, that is 4, and then the larger value, that is first we need to check what are all the values which are greater than 4. So everything is greater than 4, and another one condition is this, the center pointer is common for both 4 and 27. That is, it represents the values which are greater than 4 as well as lesser than 27. So which are all greater than 4 as well as lesser than 27? Only 26 is greater than 4 and it's lesser than 20. So we are writing 26 here. Similarly, this 27's right hand side node will be containing a copy of 27 as well as the values greater than 27, that is 28. Okay, so now we have inserted the value still 4. Okay, so this keeps on, the tree keeps on growing like this. So in the step 5, so again we need to insert 7. So the same situation happens here. Since we need to insert 7, what actually happens is this 7, we need to compare it with the root node. Since it is uh, greater than, first we are comparing it with 4, it's greater than 4, so it should come here, and it's also lesser than 27. So in this position only we can able to insert 7, but it is not possible because already 2 elements are there. Again we need to take the middle, where again we need to arrange these values and we need to keep the middle value, and again the 7 will be going up. Since we cannot up, it has to be moved. Again here we are facing the same issue. Here 2 elements are there, so then what we cannot insert. Then again 7 has to be taken as the root node, and based on that we have to arrange those elements. So what we are doing is we are trying to, let me the same thing. Here we are trying to insert, but we cannot insert here. So this you have to understand. Here we are inserting. Since already 2 elements are there, we cannot insert. So the 7 goes to the upper side. So here also 3 elements are there, we cannot insert. So it occupies the topmost position. So the top node is, or the root node becomes 7. Then, so here again these all the values are there, that we have to rearrange. So what are all the remaining values? 4, 27. So in the lower node we have 4 and 27. And one thing here, the node, while inserting this, it's not able to accommodate here. So we are just, it's not possible. So we are just going to the upper node. Here we are not, it's not possible. So that what we are doing, we are just taking these 3 values, 4, 27, and the middle element is going upper side, and this 4, since it is lesser than, it will be coming as the left hand side node, and the right hand side node we will be having 27. Okay, then the remaining values, that is 3, 4, 26. And one thing, you may get a confusion that, as I earlier said, 7 should be the values lesser than 7 should be coming left hand side, and the values greater than 7 should be coming here, as well as one copy has to be maintained, I said, because since the 7 will be coming in the lower node, actually in the B plus tree. So what we have to do is till before the step 5, So if we see the elements that we have inserted, all the elements will be coming in the leaf node. So this is one of the property of the B plus tree, that is in the leaf node, all the elements inserted so far will be there. So if we want to, for example, if we want to retrieve all the elements in the tree, then no need to start from the root node. Just we can go to the leaf node, and then from there we can access all the nodes. So that's why what we are doing is we are not keeping a copy of 7 here. Instead of that, we have to keep the copy in the leaf node. So for that, what I am doing is the lesser value is kept as 7, and the greater value, instead of 7, I am not taking the copy of 7 here. Instead, I am keeping the greater value as it is. So then what I am doing, the left hand side, what are the elements lesser than 4, the 3, it will as it is, it will come as it is. And then greater than 4 and lesser than 27, in between this, greater than 4 here, as I said, in the leaf node we should maintain a copy. So in the intermediate nodes, there is no need to keep a copy of the root node. In the leaf nodes alone, we have to keep the copy. So here 4 it's there, and then so the greater than 7 it will be coming here. So lesser than 27 we have 26. So we have to keep 26 as well as a copy of 7, and then in the right hand side we need to keep the copy of 27 as well as 28. Okay. So from before the step 5 till step 4, there is only 2 levels. That is one is root node and another one is leaf node. As per the rule of a B plus tree, the leaf node should consist of all the elements. So that only we are just maintaining another copy, which is of the elements that are present in the root node. Suppose if we are not writing the 4 here, if we are writing only the element greater than 4 and 26, then 4 will be missing in the leaf node. So that only say in order to satisfy the property of B plus T, we are maintaining a copy. So the same thing we are doing here. So if we here the 4 is repeated here, 27 is repeated here, but 7 is not repeated. So that only since the 7 is between 4 and 27, we are just writing here. So and then coming to step 6. Coming to step 6, the same thing is followed. So just come to the left hand side page. Since it is taking too much to write, I will explain. So the same thing will be repeating here. Yes. So step 5, step 6, consider this. Again, we have to insert the value 26. Sorry, 9. We have to insert the value 9. Okay, the same thing happens here. Here only we have to insert the value 9. Nine has to be inserted here. Since there are already 2 elements, this 9 has to be taken before. So then the 9 will be since it is lesser than 27, it should come before 27 has to go afterwards. So that only they have modified like this. So the tree will be modified in this way. So here they are trying to insert 9. Since it is not cannot be done, it's going here. So this 9 here, 27 here. And then we have to maintain a copy of 9 here. So for that only the same thing is happening here. 7 is lesser than 7, 4. And then the right hand side the greater values. 9 is, we try to insert the 9 here. Since it cannot be inserted, it comes up. So 9 and 27. So this node, they are saying this node. So 9 and 27. So the values lesser than 4 are kept here, and then greater than 4, one copy is greater, and no other elements is greater than between 4 and 7. So only after 7 only there are elements. So this 7, on one 7 value is there, so we are just keeping here. This 9 we tried inserted here, it came here. So the values greater than lesser than 9 or 7 is there, so it comes there. So in between 9 and 27, since the 9 has to be maintained a copy, 9 is greater here, 26 and 27, 28. So this keeps on going. So and another thing, 46 we are trying to insert. So these 46 actually it is great. If we take this 46 and try to insert, actually in this node it has to be inserted. We are trying to insert here since 46 is greater than 7. We are coming here, and then it is greater than 27 also. So greater than 27 in the sense we are coming here. Here already there are two elements, so 46 cannot be inserted. So for this 27, 28 and 46 we are finding median. So the 46, 27, 28, 46 will be coming. For this we are taking median. So here the 28 will be going upside, that is this 28 will be going here. So that's what happened. 28 will be going here. Since again already two elements are there, again among these three we are finding the middle element, so that will be going upper. So this is what happens. The 27 goes up. Again we have to order lesser than 7, 4 and lesser than 4, 3 and another copy. Between 7 and, since 27 goes there, between 7 and 27, 9 comes. Lesser than 9, that is 7, it's maintained, and greater than 9. And between 9 and 27, 26 is there. So that greater than 27, 28 is there, lesser than 28, greater than 28. Similarly, it happens. So this keeps on going. So in the eighth step, we are just going to insert 48. We are trying to insert 48. Again, we need to compare with the first node. So we are just trying to insert 48 here. Since 48 is greater than these two values, that is greater than 27, it comes here. So again, here 28 is greater than, 48 is greater than 28. So it has to come here. So the same thing problem happens. So here already two values are there, 48 is there. So then we have to find the median of these three values, 28, 46, 48, median. The 46 comes. So that 46 is pushed up since there is space here. 46 is accommodated, and then again we have to reorder. So up to this, the same thing will be coming. Level is then 27 is, so 28 is 27, and then between 28 and 46 is 28, and greater than 46 is 46 and 48. So then we are inserting 51. So again 51, it is greater than 27, these two values is greater than 51 is greater than these two values, and it comes here. So it is greater than 46. Again, it comes here. The same problem. Three values are there. So we again 51 for these three values, they are taking median, and the middle element is 48. So 46 and 51 will be here. 48 comes here. Again, three elements will be there, and then middle is 46, and 46 goes here, and again there are two elements, and then the breakups happen. So what did here again? So finally, what happens is, so this 51, after inserting this 51, this structure just changes. The middle element is 48, it goes there, and then here also the same problem, three elements can be. So among the three elements, we are just taking the middle element, that is 28, 46, and 48, and that 46 46 comes as middle element. So here 46 comes, and then if so, and then 46 comes here. Again, we have to reorder the structure. So here it breaks. So here we are inserting 51. So in that three elements, middle element 48 we are taking, and it goes here. Again here structure breaks. Then the middle element 46 comes here. So again three elements are there. So in that middle element 27 goes up. So the 27 goes up, less the element which is lesser than 27. So again the reorder takes place. So if we watch the last node, it contains all the elements that has been inserted so far: 3, 4, 7, 9, 27, 28, 46, 48. Everything is there. And finally, we are trying to insert 2 and 6. Since the 2 is, we have to insert 2. The topmost element we are considering, since 2 is lesser than all the nodes, it comes near 3. So here it comes. From the topmost element, we are just comparing, and it comes to the position here. So and then we are just trying to insert 6. So here it will come from near 7. So 6 will be coming, 7 will be pushed up. So now all the elements are inserted. So and one thing you have to notice, that B plus T consists of another one additional feature, is that it will have in the when we look at the leaf node, So they are interconnected to each other. So here you can see these pointers. So these are all nothing but interconnection. So the purpose of using this pointer is, uh, for example, if I want to retrieve all the elements that are all inserted in the tree, nothing you can, there is no struggle to retrieve those. What you can simply do one thing, just you can just go to the leaf node and start from the first element. So first you will be taking 2 and then you will be coming to 3, and the 3 has the address, or it points to the next element, that is 4, and then 6, 7. And two advantages are there. You can just retrieve all the elements, as well as all the elements are in ascending order. So to facilitate this feature, we are just using these pointers here. So if you go reach the leaf node of a V plus tree, the leaf node, all the elements that you have inserted will be there. No need to traverse the root node or internal nodes. Just you can simply go to the leaf node. From there you can just, starting from the first element, you can just access the consequent elements, that too in an ascending order. So this is the way of constructing a B plus tree. Thank you.